Hello, and welcome to this presentation, Understanding Sinad. In this short presentation, we'll explain what sinad is and how sinad is used in measuring the sensitivity of radio receivers. We'll start by defining what we mean by sensitivity. Sensitivity describes the ability of a receiver to detect and/or demodulate a received radio frequency signal. More specifically, sensitivity is a way of quantifying the weakest signal that can be reliably received. Better sensitivity means a greater ability to receive and extract information from weak signals, and in most cases this is a desirable quality. Sensitivity is particularly important when comparing receivers, and manufacturers usually include sensitivity in their receiver specifications. Sensitivity measurements can be made for both analog and digital signals, but in this presentation we'll be discussing only analog sensitivity measurements. There are two main factors that reduce receiver sensitivity. The first of these is noise. The level of the signal compared to the level of noise is usually expressed as the signal-to-noise ratio, or SNR. A higher SNR means that the desired signal pokes up more above the noise, and this makes it easier for a receiver to detect and/or demodulate the signal. As noise increases, signal-to-noise ratio decreases, and this makes it harder for the receiver to detect the signal. In addition to noise, the other main factor affecting receiver sensitivity is the presence of distortion, often in the form of harmonics. Harmonics are copies of a signal appearing at integer multiples of that signal's frequency. For example, if our fundamental signal is at 1000 Hz, harmonics will appear at 2000 Hz, 3000 Hz, 4000 Hz, etc. Harmonics and other types of distortion are not uncommon, so when measuring receiver sensitivity, it's important to consider the effect of both noise and distortion. We quantify sensitivity by answering the question, how much RF input power is required to produce a useful or intelligible audio output? This, of course, requires that we define what we mean by useful or intelligible. We could define sensitivity in terms of signal-to-noise ratio, or as the minimum discernible or detectable signal level. The problem with using SNR and MDS to quantify sensitivity is that both of these only consider the effects of noise, not distortion, and distortion does play an important role in the practical sensitivity of a receiver. Therefore, the most common quantity used in receiver sensitivity testing is something called sinad, which stands for signal, noise, and distortion. As the name implies, sinad does take into account both noise and distortion. Although SNR and MDS are sometimes specified when making sensitivity measurements, sinad is, by far, the most common method used when specifying the sensitivity of analog receivers, in particular FM receivers. Sinad gets its name from the three components that it measures. It's the ratio of the sum of signal power, noise power, and distortion power to the sum of noise power and distortion power. Because it's a ratio of powers, sinad is expressed in units of dB. The most common application for sinad in the radio frequency world is measuring the sensitivity of FM receivers, but sinad can also be used for measuring AM or single sideband sensitivity as well. Sensitivity is specified as the input level that's needed to produce a given sinad value. The standard sinad value used in almost all analog receiver testing is 12 dB. The reason for this particular value is that a sinad of 12 dB corresponds to a somewhat noisy, but still intelligible audio output from the receiver. So our goal in sensitivity testing is to determine what input level, in dBm or microvolts, that's needed to produce a sinad of 12 dB at the audio output of the receiver. Generally, the input level begins very low, and is slowly increased until a sinad of 12 dB is achieved. In this example, our received 12 dB sinad sensitivity occurs at a level of 0.3 microvolts. Higher values of sinad correspond to better audio quality. For example, in FM, quieting, that is, the absence of any static, crackles, etc., typically occurs at a sinad value of 20 to 25 dB, and audio quality often continues to improve until sinad reaches 30 to 40 dB. Let's walk through the sinad test setup for an FM receiver. Our radio frequency signal generator is configured to produce a carrier modulated with a 1000 Hz tone and 3 kHz deviation. The generator frequency is set to match the receive frequency on the radio under test. The audio output of the receiver is passed to the analyzer, which makes two measurements. One of these measurements is the unaltered audio output, which consists of signal, noise, and distortion. The output signal is also passed through a notch filter in order to remove the original signal component. Note that the notch filter characteristics will affect the measurement. Ideally, our notch filter will remove the tone, but leave the noise and distortion as undisturbed as possible. The resulting signal, consisting of just noise and distortion, can then be measured. The ratio of these two measured quantities, signal plus noise plus distortion, over noise plus distortion, is the sinad value in dB. The generator output power is slowly increased until the target sinad value, usually 12 dB, is reached, and this input level, either in microvolts or dBm, defines the sensitivity of the receiver. So in summary, sensitivity quantifies the receiver's ability to receive weak signals. High sensitivity is usually desirable because it allows reception of signals that might otherwise not be detected or demodulated. Both noise and distortion reduce the receiver's ability to hear weak signals, that is, they reduce sensitivity. Although there are various ways to define and measure sensitivity, sinad is the preferred method for measuring sensitivity in many analog receivers because it takes into account the effect of both noise and distortion. Sensitivity is typically reported by giving the input level, in microvolts or dBm, that's needed to produce a certain sinad value at the audio frequency output. A sinad of 12 dB is almost universally used because it corresponds to a somewhat noisy but still intelligible signal. The test procedure for determining receiver sensitivity consists of gradually increasing the input level until the target sinad value is found. And finally, a notch filter is used to remove the signal component from the received audio in order to calculate the sinad ratio of signal plus noise plus distortion to noise and distortion. This concludes our presentation, Understanding Sinad. Thanks for watching.